Okay, good day, class. So for today, let's have now the life safety system. For the life safety system, we have the fire safety principles. Okay, so for the introduction, we have the definition and the process of fire. So fire is a rapid oxidation process accompanied by the evolution of heat, light, flame, and the emission of sound. So we have here the fire triangle, which is the fuel, the heat ignition, and the oxygen for the ventilation. So for the fire triangle, there are three elements: fuel, oxygen, and heat are required to start a fire. So the oxidation process will not be possible without any of one of these elements. Okay, so for the classes of fire, we have class A, class B, class C, and class D. But we also have a class K, which is new to the NFPA. So the class K is the kitchen fire. Class A is the ordinary combustible materials such as wood, cloth, paper, rubber, and plastic, etc. And for class B, that is flammable liquids and gases. For class C, that is energized electrical equipment. So you have the faulty electrical wiring. And then class D is for the metal. And how to suppress the fire classes. For class A, you can use water. For class B, exclude air from burning material. And then for class C, no water, use electrically non-conductive extinguishing agents such as gaseous system. And for class D, you have heat absorbing medium, which is not reactive but not reactive with burning metal. So normally you can use the fire extinguisher for class A, B, and C. So next is the fire growth stages. So for the stages, you have for stage 1, that is pre-flashover or growth phase. It involves flaming combustion of an item and may lead to a spread of fire or a smoldering, poorly ventilated fire with substantial smoke. Stage 2 is flashover. So rapid change from a local fire to one involving all combustible materials in the room. And then for stage 3, that is fully developed fire, that is the stable phase. So all materials in compartment are alight. Maximum rate of heat release is dependent on either available ventilation or quantity of the fuel. And then stage 4 is the decay. You have the cooling period, the gradual consumption of fuel in the compartment. So those are the stages of fire growth. And then in architectural intervention during the fire growth, so this graph shows where active and passive fire protection will play an important part during the development of fire. First is the active fire protection. You can have the detection, activation, and suppression. So you have here the stage 1 and stage 2 for the passive protection. And then for the passive fire protection, you have the resistance to heat, flame, and flames of the fire-rated construction. So you have the stage 3 and stage 4. That is for temperature for first stage and second stage, and the time for the third stage and the fourth stage. You have the slow rate of burning for stage 1. So this part here, development of heat and flame for stage 2. And then for stage 3 and stage 4, load bearing capacity of materials maintained, prevention of fire spread to other compartments. You can have that in stage. So let's now have the behavior of fire and smoke. So if you are in a fire area, the smoke usually evaporates in the air. So you have to crawl so that you cannot be suffocated by the smoke in the flame. Okay. You have here the vertical shaft or duct where the smoke will go through. There are also voids in the ceiling. So normally we have suspended ceiling. So the smoke usually will be in thin air. Okay, this one. Another illustration of the behavior of fire in closed area. So the smoke usually goes up through the vertical shaft or duct, okay, outlet to adjoining space. Fire spread, this is for internal fire spread due to or between floors. So this is a sample compartment or sample room. You have there the vertical shaft or duct, this is ducting and the ceiling. Origin of fire, and then the smoke goes through the shaft or maybe goes through the ceiling. You have through vertical shaft, and then maybe also through air duct, and then passes through the other compartment. Since maybe you have this a fire uh, resistant door. So through ceiling and collapse partition. So non-fire rated doors, external fire spread due to congested high fire load areas. So you have the origin of fire, the loss of integrity of the firewall. So normally you can have a firewall. So if you have to construct a firewall, it should be 6 inches thick, so that maybe you can have at least 5 hours before the fire will go through your building. The loss of integrity of firewall. So normally a firewall should know, so maybe firewall should not have any opening. And then proximity of buildings. You have the origin of fire, the ignition of material, this one. Then the convection current. So you can, so why do you think that the fire from here will continue to another building? Because of the kiln temperature. Kiln temperature, maybe a material is heated through this fire and then it ignites. Okay? So that's the uh, I think that's the temperature where the materials will ignite. Okay, that is the flash point of the material. So aims in fire safety design. So A is to prevent a fire, and then to safeguard the lives of occupants and firefighters. Then you have to reduce the damage on the building, its content, and on surrounding buildings. So for the basic principle, you have the fire avoidance, fire detection, fire growth, restriction, fire containment, fire control, smoke control, and the escape provision. So this should be included in your design. The basic principles. First is the fire avoidance. So definition and application. So reducing the possibility of accidental ignition of construction material as well as fittings and fixtures. So this implies A, keeping separate heat source and materials which might ignite readily through proper planning and zoning. Letter B, you have need to specify materials to reduce the risk of fire starting. So maybe you can have a storage area which separates the material which is easily ignite and maybe a material that uh, can be ignite through fire. And reducing fire load. So reducing fire load is to store material, maybe not unclaimable material, so lessen the use of claimable material. So for example, you have in hospital, for fire zoning. So you have life risk area. This is where the area in which all occupants are ambulant and able to move unaided away from a fire. Example, the outpatient department or the service zone. So I am exampling here the hospitals in. There are four areas in fire zoning, since only three for the other buildings and four for the hospital. So this is for most buildings, the life risk area, and then the high risk areas, areas which due to their functions are more usually susceptible to an outbreak of fire or to a rapid spread of fire or smoke. This is for example in kitchen or in boiler room. And then high fire load areas, areas which because of their construction content contain large amount of combustible material, thereby constituting a fire load in excess of that normally found. Example is the gas storage and linen closet. And then for the number 4, this is for hospitals only. This one, the high life risk areas, so areas in which persons may reside and are not able to move unaided away from the fire, especially in ICU or in the operating room department, okay, or in the operating department. Example, for the fire zoning, you have the life risk. So life risk is areas which all occupants are ambulant and able to move unaided away from a fire. So you can move easily away from fire. One. Next is the high risk. So for the high risk areas, due to their functions, are more usually susceptible to an outbreak of fire, especially, or example is kitchen and boiler room. The green one. Okay. Next is the high fire risk. So there is where the material is stored, and then the high fire load is, that is the ICU in hospital or the operating room in hospital. Next is the choice of materials and knowledge on material performance. First is concrete. It is high fire resistant. So this integrates at 400 to 500 degrees Celsius. Holes in concrete will expose steel structural members. Next, we have steel. Does not burn, may buckle in fire. High conductivity spreads heat, then loses half of its strength in 550 degrees Celsius. Another is timber. This is combustible, little loss of strength as charcoal forms, insulate wood core, then spread flame. Another is the masonry, that is high fire resistant, cracked at 575 degrees Celsius. This is subject to high temperature during manufacture. And then calcium silicate. This is used for cladding and sealing. So excellent thermal shock resistance, up to 1000 degrees Celsius, suitable for cladding structural members. And then the glass, that is standard float tough strength, and laminated glass panels. This is panels, but do not provide any fire resistance. So monolithic fire rated glass is available. These are the materials of choice. So maybe you can use concrete, masonry, and steel for your building. But in hospitals, they have used the concrete, masonry, steel, glass, and maybe a timber. I don't think the calcium silicates are to be used in hospitals. Next is the knowledge on the fire load. So the amount of material which is able to burn and release heat and smoke. So in a compartment, limiting fuel will help reduce the danger of heat and smoke. So building contents make up the majority of the fire load, since most fires start from the ignition of this content. So the total amount of fuel in a building its accessibility to fire engines, the ability of water, etc., will determine the level of fire resistance and the maximum size of the building compartment. So it depends on the building compartment. No? So you can have the wood table, so that is a fire load. Maybe a sofa, also a fire load. So you can determine the accessibility of or the availability of water in the area to know the maximum size of the compartment. Next is the fire detection. So you have the visual fire detection. So for visually exposed fire risk and fire load areas to building occupants. You have, for example, this is the hospital. So a nurse station. You have the patient room, and then the storage and the lounge. You can see from the nurse station, you have the patient room, the storage, and the lounge. Maybe this is for architects to design the hospitals, but at least we know about the basic knowledge of design for hospitals. Visual fire detection. So fire-prone areas should be visibly, visually accessible. Then provide peepholes on doors. So mostly in hospital, you have here the glass or the peepholes so that you can see the rooms or the compartments. Another, they just use sliding glass doors. So mechanical fire detection. To make use of manual and automatic, electric or electronic methods of informing the occupants in charge that a fire has occurred in a given location. You can have the fire detection, the heat detector, and the smoke detector. Heat and smoke alarm system inside fire risk and fire load area. You have here the fire alarm system must be accessible in all zones, especially in fire-prone areas. So normally, in hospitals, in every room, they have the fire alarm system or the smoke or heat detectors. Next is the fire growth restriction. So manual means of restricting fire growth. It aims at ensuring that the growing fire is extinguished immediately and at providing adequate time for firemen to arrive or control the fire and evacuate the occupants. So actively extinguishing or slowing down the development of fire before the full involvement of the room. This is done by the room's local occupants. So means by the means of fire extinguisher, water supply, you can have also a fire blanket and a bucket of sand. So this is an example of a fire extinguisher. Rating of fire extinguisher. So for class A extinguisher, so we'll put out fire in ordinary combustibles such as wood and paper. So for class A extinguishers, so that's for class A fires. Okay. So the numeral rating for this class of fire extinguisher refers to the amount of water the fire extinguisher holds and the amount of fire it will extinguish. Next, we have the class B extinguisher should be used on fire involving a flammable liquid such as grease, gasoline, oil, etc. The numeral rating of this class of fire extinguisher states the approximate number of square feet of the flammable liquid fire that a non-expert person can expect to extinguish. So by the way, in operating the fire extinguisher, you have the keyword pass. Pass means hold the pin, aim, squeeze, and spread. And then you have also class C extinguishers are suitable for the use of electrically energized fire. The class of fire extinguisher does not have a numeral rating. The presence of the letter C indicates that the fire extinguishing agent is non-conductive. Then class D, extinguishers are designed for use of flammable metal and are often specific of for the type of metal in question. So there are no picture designator for class D extinguishers. So these extinguishers generally have no rating, nor are they given a multi-purpose rating for the use on other types of fire. Okay, so there's a type of fire extinguisher. First is the dry chemical extinguishers are usually rated for multi-purpose use. So they contain an extinguishing agent and use a compressed non-flammable gas as a propellant. So this is normally used maybe in buildings which do not have a sprinkler system. Next is halon extinguisher. Contain a gas that interrupts the chemical reaction that takes place when the fuel burns. This type of extinguishers are often used to protect valuable electrical equipment since them leave no residue to clean up. Halon extinguishers have limited range, usually 1.2 to 1.8 meters only. So the initial application of halon should be made at the base of the fire even after the flame has been extinguished. And then the carbon dioxide extinguisher are most effective on class B and class C, liquids and electrical fires, since the gas disperses quickly. So these extinguishers are only effective from 1 to 2.1 feet. So the carbon dioxide is stored as a compressed liquid in the extinguisher. As it expands, it cools the surrounding area. The cooling will often cause ice to form around the horn where the gas is expelled from the extinguisher. Since the fire could reignite, continue to apply the agent even after the fire appears to be out. Okay. So next is mechanical means of restricting fire growth. So we have also a sprinkler specification. This is, I think, upright and pendant sprinkler head. So for the categories, general use, institutional, you can also have in residential, attic, special hazard storage. 3 heads, you have upright, pendant, and side walls. And is rated to 175 PSI or pounds per square inch. The sprinklers can be spaced from 3 to 6 meters apart, or you can have 3.6 to 6 meters apart. Since a sprinkler can occupy at least 10 to 20 square meters. So for fire containment, definition and application. So assumes that measures to control a growing fire may not be successful, hence its maximum size needs to be restricted both to reduce the risk and to allow effective firefighting. So this implies fire cladding of structural components to ensure stability of the structural frame. And then number 2, the use of fire-rated walls and slabs to contain fire in rooms, sub-compartments, and compartments so as to segregate areas where fire may occur. Okay, and then number 3, you have plugging all holes, extending CHV walls up to the slab. Okay, so you have the fire containment. So instead of your CHV is up to the ceiling, you can have it up to the flooring. Okay, flooring of the next level. And then providing a 1 meter ledge to prevent fire from creeping up exterior walls into the floor above the windows. You can have a canopy, which is a 1 meter canopy, this one, to prevent the fire from keep creeping up exterior walls into the floor above through the window. Next is the concept of fire compartmentation. For the definition, containing fire-prone areas by means of fire-resistant inclusion. Objective, to limit fire and smoke spread, to allow longer escape time, and to reduce the maximum potential size of the fire. So you have the first compartment or a room, the next compartment, that is the subcompartment, and the last room, that is the compartment. It should be a fire-rated sources. For the compartment size, the more combustible the contents of a building, the smaller the compartment should be. The joints must be filled with non-combustible material to prevent the spread of smoke or flame. So you have this concept. So you have the rooms for the Legion. So that's the rooms. And then the department. So that's compartmentation. Compartmentation, you have the rooms, smaller rooms, and then the department. Next, we have the fire rating of construction system. So concrete masonry walls, wall units for 4 inches hollow block, for 4 inches each way, you just have 2 hours. And then for 6 inches, you have 4 hours. So that is why the 6 inches hollow block will be used in outer wall and the firewall. And then for inner walls, you have 4 inches hollow block. And then for gypsum walls, 1 hour for wood and steel, and 2 hours for double walling or double layer for wood and steel. 1 layer, 1 hour, 2 hours, double layer. So for ceiling system, so you have 12 mm gypsum board, that is 1 hour. And then for 12 mm board applied to drywall paring, this one, of 2 hours. And then you have steel runners, and you have this, I think, an I-beam. So that's 3 hours. You just go through with this class. No? I already have you maybe downloaded a copy of this slide. You just go through with this slide. And then for door openings, so for 1.3, that is the maximum, you have 1 hour. And then for this one, that is 2 hours. And for the flush metal door, that is 2 hours. So for 1.2 by 3 meters, single hollow metal door, gauge 20 steel face with labeled single point or 3-point latching hardware steel hinges for 5 volts. This is for hospital. So load bearing capacity, integrity, and insulation. So for load bearing capacity, to collapse or excessive deflection of the structural member. The structural performance, building still stands during an emergency. Ability to carry loads without collapsing. So in designing a structure of a building, you will have also to consider the fire emergency. Maybe for heating your material to collapse the building, or to collapse the level above your maybe an origin of fire. So maybe I think you can use steel bars or reinforcing bars that is high capacity for heat. For the integrity, the passive of flames, ability to resist the development of crack or perforation so as not to allow passage of smoke and flame. So that is for the concrete. For the load bearing capacity, that is for steel and concrete. And also for the bonding. Next is insulation. So temperature increases. So insulated building elements will not ignite in fire and will ensure passage of human beings without damage on the other side of the separating element. Ability to prevent heat transfer from one phase to other phase. So normally we'll use the concrete material. Next, we have the fire control. The definition and implication. So covers those devices and systems which aid firefighters in actively extinguishing the fire and bringing it to an end earlier than a pre-burning fire. You have the access roads. So normally when you design, you should have a road right of way for the access road for the fire truck. To ensure that all areas inside and outside the building are covered by reach of the fire hose. Okay. So you can have your fire hose at the center. Site access for fire control. The fire apparatus should have unobstructed access to buildings. Bollards and fences used for traffic control must allow for sufficient open road width for the fire truck. And then you have prevent time-consuming hazardous backups and dead ends by using T-horns and cul-de-sacs. You have the roundabout, T-horns or roundabout. And then place hydrants or place fire hydrants at maximum 3 meters from the curb. Siamese connection to standpipes must be visible and within 60 meters from the fire hydrant. Okay. So normally a fire hydrant is accessible from the road or from the curb, and then the Siamese connection should be visible within 60 meters. You have the fire hydrant. Hydrant must be unobstructed. Fire hoses connection should be at least 0.3 meters above the grade. So normally you see this fire hydrant in roads along the curbs. So utility poles, kiosks, sculpture, fountains, plant boxes can impede fire rescue operation. So normally you can have, if you have these poles or can obstruct the fire truck ladder maybe to your building. So next is fire truck. The aerial apparatus specification. So normally you have these distances to the building. So approximately for 10-story building, so the distance from the building to the fire truck, you have 8.5 meters. So you just go through with this class. So concept of firefighting shaft. So provides access to a building, especially in high-rise buildings for fire brigade. It is fully equipped with firefighting equipment, service elevators, stairs, and a lobby. Provides a sufficient secure operating base and a rest area in between firefighting operations. Stairs, fire-rated doors, elevator shaft. So next we have the smoke control. So definition and technique, measures which can assist to some extent occupants in the fire zone but are particularly needed for others in adjacent areas or compartments. So techniques of smoke control, first is by smoke containment or smoke barriers. The technique of restricting the movement of smoke by the provision of the fire resisting elements. And then also you have smoke dispersal technique for clearing smoke locally by provision of natural cross ventilation or mechanical venting. You have the smoke barriers, one, and extraction of smoke sealing reservoir. So this is venting, smoke dispersal. Smoke barriers, then smoke dispersal. And letter C is the pressurization. This technique whereby air is blown into a space which are designed to be kept clear of smoke. This one. So the low pressure where the smoke can travel through and then through the high pressure. So use barriers including walls, floors, and doors to contain pressurized air generated by mechanical means to keep smoke away from protected areas such as escape, staircase, and corridors. So next is escape provision. The definition, you have cover a range of passive or active system which permits the occupants to move or be moved to a place of safety within or to the outside of the building. Corridor system. So direct, not tortoise, tortuous, simple layout, this one. No barriers, cul-de-sac, that is roundabout, bottleneck, doors open out, not in easily detectable, not hidden from the view. Fire escape. So fire escape stairs designed to be used daily for familiarity of escape route, then well maintained, not used as storage of junk. We have also protected escape routes. So to provide safety, the routes must be properly protected from the effects of fire and smoke for an acceptable time period, usually a minimum of 60 minutes. So this can be achieved by compartmentation, fire resistance of escape route structure, use of smoke control system to keep smoke out of the escape route. The protective escape routes are designed in such a way that they lead to a place of safety. And once inside the occupants are safe from the immediate danger from fire and smoke. So normally the fire escape provision is through stairs and fire exit. Escape route leading to this one, protected escape route. Maybe walls of that escape route is fire rated. Protected lobby, then protected stairway enclosure. Also, we have alternative means of escape. You have the place of escape. The alternative means of escape doors should be as far as possible from each other, preferably on opposite walls. Both doors should not open into the same compartment. Example, this one. Compartment 1, another compartment, and another subcompartment. It should be that the doors preferably open opposite the wall, opposite walls. And both doors should not open in the same compartment. Next, you have the access through the courtyard. The design of fire resisting door. The required width of escape route. So this is from the fire code, at least I think 2.4 meters. This one. Required width of escape route. And then design width of the fire doors. So this is 1 meter. I think this is for 2 doors, that is 2 to 2.4 meters. Primary consideration in the design of fire safety of hospitals. So the presence of patients with various degrees of deficiency, depend, dependency, and immobility on one hand, and the constant presence of the staff on the other hand. It is assumed that there should be no reliance of external rescue or such manipulative types of escape appliance as chutes and fire ladders. The staff, the staff would be fully responsible in assisting patients within their area of control to a place of safety in an emergency. Next, we have progressive horizontal evacuation. So maybe you already seen an evacuation plan. For example, in malls, they should have an evacuation plan. And also in CIP, we have our evacuation plan. Okay, so that's the end. Thank you for watching and listening to this video discussion. See you on our next topic. Thank you.